before I introduce our next speaker, I'd like to make a remark. We have a very unique situation in Russia. 7 from 10 biggest cable company in Russia uses the one IT solution for cable industry. In spite of the fact that we have very, very competitive atmosphere in market of IT systems. SAP, Oracle, Microsoft are very strong in Russia, are very strong in steel industry, metallurgical, non-ferro industry, and telecom, but only one small Ukrainian company become successful in Russia. Why? I hope CEO of this company, the name of this company, Chloe, based on Kiev, based on Ukraine. They have offices in London and in Moscow and Kiev, of course. Tonabrinsky tell us about why so successful in Russia. I hope it will be interesting for you.
Good afternoon, ladies and gentlemen. I'm pleased to be here today and talking to you. As Andrei said, my name is Tonabrinsky. I'm CEO of Global Company, a provider of business application. First of all, I would like to thank the organizers of this event and company Uncomtech for the invitation. Thank you very much for the opportunity to share our experience. Why I'm here today? And what is the most important things in my presentation? In my presentation, I will show real examples from real companies of gaining benefits of using elements of Industry 4.0. 3 main of them are how to reduce time to market of new products for more than 10 times, how to produce by 20% more with the same equipment, and how to fulfill all customer orders on time, and how to reduce the equipment maintenance and repairs cost by 8% without loss of quality and the output volumes. Our partners from Uncomtech filmed several short videos on the use of Industry 4.0 elements in their production, and I will show you these short videos. Today I will talk about such modern standards and approach of business management. They are such as the new ideology Industry 4.0. I like to tell a bit of a history of Industry 4.0, and I will tell what Industry 4.0 is capable to do for you. The Internet of Things, an opportunity of simultaneous interaction between equipment and people over the Internet, and cloud computing and big data. They provide virtually unlimited possibilities of computer technologies that did not exist before. Now they have become available for minimum cost. The intersection of these new opportunities, technologies, and approaches has allowed to create a new management philosophy, Smart Factory. And today I will talk about this intersection in cable and wire industry. First of all, let me introduce in few words our company and to explain why I'm talking about these things today. Our company Globi operates in the market of business management application, and in particular the management of industrial companies and industrial holdings for more than 30 years. Solutions for cable and wire industry is one of the most significant solutions in our portfolio. We have completed for more than 300 projects all around the world. And as Andrei said, more than 50% of cables produced in Russia, Ukraine, Kazakhstan, and Belarus manufactured under control of Globi system. Our partners are world IT leaders, Microsoft, Oracle, Intel, and others. Here you can see some companies that use our solution in their management practice and implemented elements of Industry 4.0. There are large cable and wire industry companies such as Uncomtech Group, KM Cable, CF Cable, Yush Cable, and others. Also, we work with many other industries and companies. For example, Privat is #1 company in the world in producing and manufacturing of ferroalloys. Interpipe is also a very large company that shares the leading market share and takes 4th place in the world of pipe producers. And Antonov Aircraft Company, which builds the largest known cargo plane today, RIA, and many others. What is the history and idea sources of Industry 4.0? The name. Industry 4.0 means Fourth Industrial Revolution. During the First Industrial Revolution, with the help of power and steam, production was mechanized. During the Second Industrial Revolution, the main driver was electricity, which made possible the mass production. Henry Ford's revolutionary assembly line, one of the most vivid examples of the Second Industrial Revolution. The industrial electronic devices and information technology were in the center of the Third Industrial Revolution. It was the base of development of computer-aided manufacturing. It characterized by appearance of the first production line with management controllers. What is the Fourth Industrial Revolution? Maturity of the internet technologies, cloud computing, and big data was followed development of fundamentally new possibilities of interaction between people and machines, which is called cyber-physical system, working with the internet. Why Industry 4.0 came to life? The dynamically developing enterprises in China have begun to play an increasingly prominent role in the global scale. Western Europe and the United States, faced with the problems of competitiveness of their products of mass production. As a result, they were losing the battle and customers in this competition. The Industry 4.0 concept was developed due to the efforts of representatives of German industry. Then it was adopted by many other countries in the European Union. In 2011, Germany established a state-sponsored program, Industry 4.0. An important event was that in 2014, both leading private industrial companies of the United States, General Electric, AT&T, Cisco, and others, have created a non-profit consortium of industrial internet. What are the main differences between Industry 3.0 and Industry 4.0, so-called smart factory? The third industrial revolution focused on mass production. Production capacities were transferred to the countries with cheap labor. Industry 4.0 focused and emphasized maximum product personalization and customer satisfaction. The goal is to quickly produce what clients require. In Industry 3.0, staff control and participate in production process. In Industry 4.0, people design new product and the system synchronize equipment and personnel in production. Now, I want to give you a real example of the application of Industry 4.0 in everyday life. The future is today. Please imagine, you are in your office, you press the button with your smartphone, tell the address where you need to go, you go in to the street and your car arriving from the parking. You sit down and the car takes you to specified address. You calculate the optimal route based on the traffic information and other factors.
Where would you like
All
to
necessary
go today?
information your car resides from the cloud, interacting with the internet. If the situation of the road has changed, your car autonomously recalculate the road and deliver you to destination location. I think that it's a little bit more modern things that just use car with smartphones. What element of Industry 4.0 in this short video and how this concept works in production? Specifies the destination of the road. This is a reception of production order on the specific products. It's a demonstration of interoperability principle. The ability of people, machines, and devices to interact using Internet of Things. Second, devices in smart factory can make decisions. Reschedule production in case of the changing condition, order cancellation, raw material shortage, etc. As well as cars can autonomously rebuild road when road situation changed. Its decentralization principle implies the ability of the system to make decisions autonomously. And third, it's real-time capability. It's real operational information on the state of the manufacturing processes. What's going on in production? It's a similar to situation and navigation system reports our location. This is an example of usage elements Industry 4.0 in production, an example of smart factory. And one of the most important things that Industry 4.0 allows you to get a measurable economic benefit. Here I want to refer you to the August report of the consulting firm Mckinsey on the impacts of Industry 4.0 to the manufacturing companies. What is the added value of the new production technologies? Let's review just some of indicators and see how it works in practice. Time to market. Industry 4.0 allows to achieve 20 to 50% reduced time to market for a new product. 20 to 50%. Asset utilization allows to improve equipment performance by 20 to 30%, usually called as overall equipment efficiency. Labor automatization allows to increase productivity in technical profession by 45 to 50%. Let's review the examples of usage of elements of Industry 4.0 in through processes, from receiving the individualized order to the design of the product and engineering the production technology and to production of finishing products. Consider the case number one. One of the key elements of Industry 4.0 is time to market. Let's review it. What is the real-time interaction between customer and the manufacturer? The customer specifies certain parameters and requirements of the order referring to the sales department. Then, sales department is requesting R&D department, if we can accomplish it. If it's possible, R&D department design the products and engineer production technology. Usually it takes much time. Only then, economic department calculates cost price and production department estimates lead time. And only after that, sales department can inform the potential customer about calculated price and the estimated lead time. This classical process takes from several days to several weeks. During this time, the customer can cancel the order or change its settings or parameters. In modern production ideology, all these tasks can be done within a few minutes. And all customers and potential customers will be satisfied. Global cable designer can provide automatic design of the product and engineering of the manufacturing technology for specific order, and to design whole product line if necessary. The goal is to reduce estimation time of the order. What's inside Smart Factory? What is the secret? We use unique methods of mathematical optimization based on heuristics, and specifically customize them for cable and wire industry. The mathematical implementation of production scheduling in CLOBI is based on the theory of scheduling and theory of constraints norms from works of Eliyahu Goldratt. To optimize equipment and personnel capacity planning, we use such specialized APS, MAS algorithms as Grady algorithm and genetic algorithm. Why we use these algorithms and approaches? Lead time calculating and production planning in the cable and wire industry is extremely complex task. It has thousands of parameters and unlimited number of solutions. If we try to solve this task mathematically, we can use classical approach, branch and bounds method. But problem is that it will take us at least 1,000 years just to calculate the results by using state-of-the-art modern computers. I don't think anybody will wait 1,000 years. Do you? We have developed an innovative solution and applied mathematical heuristic, modeling, and genetic algorithms that allowed us to solve this task literally in the matter of the minutes. This is a revolutionary solution. Here is a short income tech example from their practice, from one of the biggest cable producer in Western Europe. During 5 minutes after receiving the order, IT system provides automated calculation of the product design and production technology, as well as calculation of the production cost of the ordered products and its lead time with using of information about current capacity situation in production and situation with other orders. Implementation of CLOBI cable designer module in Uncomtech company allowed to achieve following results. First of all, reduced response time to the client's request from weeks and days to minutes, and reduced development time, R&D time, by more than 10 times. And also involving consumers in creation of the product line and rapid development and manufacturing. In the case number 2, we consider the optimization of equipment and personnel in production. In the concept of Industry 4.0, they correspond to asset utilization and labor of the Mckinsey's report. After the design stage, the company proceeds to production stage. The focus of Industry 4.0 is to individualization and speed. This leads to a substantial increase of the number of orders, since each order is individual. This also requires to increase the production rate. Under such conditions, frequent changeovers of equipment, which must be done quickly and cost effectively, are critical. Another critical factor is getting supply of necessary raw materials timely. Who is responsible for these things? Workers are responsible for equipment changeovers and to provide required amount of materials. But workers have to work in synchronization with equipment. With large number of orders and changeovers, even short delay of workers for a few minutes can lead to a delay in execution of many orders and to failure of whole production schedule. In the past 5 years, we have worked with over 100 different companies and cable and wire producers. We've done a research of this problem in the cable and wire companies, and conclusion is that over 70% of delays in the release orders are due to decentralization of equipment and workers. How to solve this problem? There are only 2 ways to do it. Way number 1, entire manufacturing lines have to be replaced with a totally new equipment, which is able to do effective changeovers and to provide inventory supply by itself. Is it possible? Is it possible? This is the way of current global development, but to replace simultaneously all the equipment and manufacturing process is extremely difficult, if not impossible. And the way number 2, to minimize manpower in production and to synchronize equipment and workers by using such things like Internet of Things tools. This is a solution that is available right now, and I want to tell you about this way. It allows you to cost effectively solve the problem of delays in the execution of the production program. In this way, production management system must interact with equipment and workers. This interaction is the Industry 4.0 element which should be executed automatically. It's very important, automatically. As is clearly from the example of a navigation Tesla car. Main goals of Industry 4.0 elements usage in this case are improve customer service level, maximize and execution of customer orders on time, and improve the efficiency of the equipment. 2 main key performance indicators. Let's consider the example of Industry 4.0 elements usage. First of all, system calculates the optimal schedule of the equipment utilization and working personnel using smart factory mathematical optimization mentioned above. This schedule is automatically distributed by our system Globi to the equipment and automatically distributed to the workers. I will show how it works. Workers receive the guidance list and their scope of task on their tablets or smartphones to keep them focused and be efficient. Equipment and workers execute their tasks and key performance parameters are achieved with each department of the company and on every stage of production. If there are any change in the equipment and personnel, Globi system automatically reroutes the production that ensures timely delivery of ordered goods. This video shows how Globi calculates the optimal production plan at Uncomtech company. We can see the list of equipment at the left side and its optimal schedule at the right side. The system also planned the schedule for the workers. This schedule allows to fulfill all orders on time and without extension of existing equipment. Here, we see that equipment received automatically from Cloby system the production plan in real time and gets executed. The system sends the commands instruction directly to equipment and automatically gets information about production results from equipment with no usage of labor time. Cloby allows you to see what orders are being processed now and how effectively operates your equipment. You do not need to go to the shop. You can be at any place of the world. And workers receive job commands on their smartphone or tablets and immediately start to execute the optimal production schedule according to online commands, just like in this video. If something has changed, Smart Factory Optimization allows you to quickly reschedule your production plan and deliver jobs to your equipment and workers, just as the GPS navigator reroutes your way if you miss a turn. During the production plan execution, workers can register online receipt of the materials, setup and preparation of the cable drums, etc. Just by the simple use of their smartphones or tablets, which creates a great amount of convenience. The results is incredible. 99% of the orders just get processed on time. The output gets increased by 20%. 20% of increasing of output. That means the same equipment produces by 20% more. If you use Cloby system together with your manufacturing equipment, it will become unnecessary to buy additional, very expensive machinery. Maybe it's not necessary to buy it. And case number 3, also very interesting information about repair and service management, and real case from real company. The aim of this sub-element of Industry 4.0 is to increase availability of existing production assets and to reduce maintenance and repair costs. Let me illustrate how it works by showing an example of one of the biggest tube manufacturing company in the world, Interpipe company. Common practice that nowadays the most of the equipment in manufacturing plants is serviced according to the basis of preventive maintenance. Repairs or replacement of necessary parts and components of the equipment done after predetermined time has passed. The same situation applies when we change oil in our cars. For example, every 10,000 kilometers or 20,000 kilometers in different cars. Leading global companies perform statistical analysis. Which equipment is most often going down and divided results by the probability of its failure to 6 groups. The probability of failure of the equipment of groups A, B, and C is time dependent and directly associated with the wear and tear of processing equipment and machinery used while processing raw materials. Usually it's a simple equipment. And the probability of failure of the equipment of groups D, E, and F does not depend on time. This is typically hydraulic, pneumatic, and electronic equipment. Very interesting that typical ball bearing is also in group F, and its breakage does not depend on time in service. It's ball bearing. The analysis of the situation in the world's largest companies found that about 80–90% of the key elements from group is in group D, E, and F. It means that probability of their failure does not really depend on time in service. That's why the preventive maintenance approach is only suitable for 20% of the equipment. Therefore, performing maintenance procedures according to this methodology leads to significant losses, the enterprise resources and money. Only 20% of equipment may benefit from preventive maintenance and repair. However, for 80% of equipment, preventive maintenance does not work and is not suitable and requires different maintenance approach. The solution is, of course, to use Industry 4.0 concept. namely maintenance of equipment based on its reliability. The indicators of reliability of the equipment measured on a regular basis. An IT system creates trends using regression. These trends analysis based on the given data that can predict the frequency and probability of equipment's failure. On the basis of this information, engineers take decisions as to when to begin the repair of this unit and when to purchase the necessary resource to avoid equipment failure. As a result of the transition to condition-based maintenance of the equipment, Interpipe Corporation reduced equipment maintenance cost to 8% in 2015, just by using this ideology. Increased equipment availability ratio by 15% and reduced the emergency downtime by 22%. It's really great results. One of the biggest company in the tube segment in the world. During this presentation, I present only some of the elements of Industry 4.0 concept. But even with the realization of these considered elements, your company can significantly improve its performance, shorten the time to market, and reduce costs so direct economic effect is achieved. It is important for each company to analyze their readiness to use elements of Industry 4.0 to develop key performance indicators that will characterize the performance of the implementation of these changes. And we have a special proposition for cable and wire producers. We propose to analyze business processes of your enterprise for free. This analysis will be done by our group of experts, which have a great experience in cable and wire industry. This analysis will show what benefits can be achieved, at what cost, and what is the payback period. We are ready to discuss prospects of cooperation. Here are our contacts, and also at your tables you have our brochures. Please don't hesitate to contact us and keep in touch. Thank you very much for your attention. If you have any question, please don't hesitate to ask me.
Now, market, I know only one IT solution for cable industry. It's a French solution, Hortense. It's not so big solution like yours, but it's Hortense. Have you ever compared you with Hortense or maybe SAP cable or another systems, made especially for cable industry? Do you know about another systems?
Thank you for this question. I like very much this question. Of course, we know Hortense, we know all other systems. We know Hortense very well because we met this system at a few plants with. And first of all, as I told, Hortense is a local solution just for manufacturing scheduling. It's just a local module of this solution, and it can do only the plan for the 1 week. For planning for the for bigger period, it is really difficult with this system. Our system is integrated management system. We cover whole production management chain, orders, production planning, execution, integration with equipment, analysis, etc. And our system considers the specific of cable and wire industry, planning of semi-products, of lengths, of planning of cable drums that can really helps to get a better schedule. And the really interesting things that we took 2 times at the cable and wire plants. We have a competition. We had a competition with Hortense system, and the customer was in process of choosing a system for managing of their company, and the task was what system will create a better production schedule. And when we use our special solution for cable and wire industry, our production schedule was by 15% much better than Hortense's solution in that time. That is the answer to the question with any analogs of these IT systems.
Have you done any implementations of parts of your system and interfaced with existing systems? So if, for instance, I might have spent a lot of money doing SAP for the financial, but might want to take scheduling or cable design from Clobby?
Thank you very much for this question. The main goal of all our implementation is to get economic benefit. Yes? And if we come to some company that have real working system in this company implemented and that works normally, we think that we shouldn't change it. We should implement the module, like the modules that I show, and get economic benefit and make an integration with the system that works, that we implemented in the company. It's our philosophy that we should implement only that modules that can gain the economical benefits. And we have the module with open integration with all systems, with SAP and many others. And a lot of our customers, our system can work independently, and also it can work with integration with other systems. And typical situation now for many companies, maybe 50% or 100% of companies have some systems in their management practice. And when we do our analysis, we analyze what system works good and it gives a good results, and it's not we shouldn't change it. We have an open module of integration. Thank you very much for a good question. Okay, thank you very much for your attention. Please keep in touch and have a good evening. Thank you very much.